Hi, everyone, and welcome to the USC Viterbi School of Engineering Faculty Roundtable Series. Today's Faculty Roundtable session is going to be with the Ming Hsieh Department of Electrical and Computer Engineering here at the Viterbi School. My name is Paul Ledesma. I'm the Director of Undergraduate Admission here at the Viterbi School. It's a pleasure to have all of you joining us today, and we have a fantastic group of faculty here from the Ming Hsieh Department to walk you through a little bit more about not only what they do in the department, but to tell you a little bit about the curriculum and what you've come to expect by studying electrical and computer engineering. So I'm going to have each of them introduce themselves, and then we're going to kind of kick off the event. I'm going to start with someone you don't see on the screen because he's currently kind of in motion right now, but he's on the phone and he's going to join us in video in just a little bit. So let's start with Dr. Sideris.
Hi, everyone. It's a pleasure being here today and meeting some of you. My name is Constantine Sideris. I'm an assistant professor at USC in the Electrical and Computer Engineering Department. I've just been at USC for a little bit over 3 years now, and my research areas are in analog and radio frequency integrated circuit design for applications in biomedical devices. And so what I mean by that are point of care sensors for example, rapid detection of COVID or other infectious diseases, wearable devices, kind of like, smartwatches that can track different kinds of biopotential signals or health markers, and also implantable and ingestible devices.
All right, thank you very much. And so we'll have him join us on video in just a little bit. Next, Dr. Povinelli.
Hi, everybody. I'm Michelle Povinelli. I'm a professor of electrical engineering, and I also have a courtesy appointment in physics. And I teach undergrads, grad students, and do research. My research is in the area of nanophotonics. So I study nano-patterned materials that interact with light in unusual ways. One of the things I work on in my group is how to make a material that adjusts the amount of light it radiates to help keep its temperature constant. So materials that could auto-regulate their own temperature and stay at a temperature that you want them to, which can be used, for example, for thermal regulation on satellites.
All right, thank you very much. And next is, I'm just going around my screen here, Dr. Kapadia.
Hey, everyone. It's great to be part of this roundtable. My name is Rehan Kapadia, and I'm an assistant professor here in the electrical engineering department. I work on kind of the fundamental materials and device side of things. So specifically, developing new ways of growing materials and integrating those materials together in ways that could potentially, address some of the challenges that we face with computer chips today. So that 10 years from now we can have processors that are as much faster then as compared to now as processors and computer chips are now compared to 10 years ago. And so it's kind of a broad area of what I work on.
Thank you very much. And last but certainly not least, Dr. Chugg.
Hey, everybody. Welcome. My name is Keith Chugg. I'm a professor in ECE department. I've been a professor on the faculty here at USC since 1996, so quite a while. And I even did my PhD at USC. So I've been around campus roughly since 1989. So a long time. It's a great place. My research area has been in the past digital communication theory and systems, signal processing, algorithms, machine learning. Currently, most of my work is focused on simplifying deep learning algorithms and models to run on custom hardware. So co-designing digital electronic circuits and deep learning algorithms to make them run more efficiently on edge devices, like even think of embedding them into cameras or microphones and those sorts of things, and doing intelligence on the edge. And I've taught undergraduate courses many times and also graduate courses. So when we talk about the USC experience, I've been around a while and I can hopefully shed some light on what you might experience here.
This is great. Thank you so much. And all those introductions definitely leave for lots to be discussed as we come back into it. For all of our guests out there, again, thanks for joining us. Here's how today's session is going to work. I'm going to lead a discussion for the first half of the session. That's all about the undergraduate experience in electrical and computer engineering. We're going to talk about the discipline as a whole. We're going to talk about the curriculum. We're going to talk about research in the department, and also talk about where our students end up after their undergraduate experience. And then the second half of the session, I'm going to open it up to you as our audience, where you're going to be able to post questions and also upvote them to see what the most popular questions are. And then we'll just go through those questions for as long as we possibly can. But for the time being, I'm going to ask you to hold your questions. So please, no questions right now. I'm going to be able to lead this discussion because I think this will handle a lot of your questions. It will also provide some context to your more detailed questions in the latter half. And also, just so you know, today's session is all about this discipline, all about this department. This is not about admission or the application process. So please hold those questions if you like. We're going to post some information in our chat here in a little bit where you can register for one of our admission information sessions where we can go over that in detail. But without further ado, let's ask my first question to our faculty. It's probably one of the easiest questions to ask. It's a simple question, or at least it seems like that, but it is a very hard and complex question to answer. So I'm going to let you try to all deal with it. What the heck is electrical and computer engineering? Can you tell us what this is? And I know it's such a broad answer. I'm leading you down this rabbit hole, but do the best to help us understand what the discipline is. Who wants to take the first shot at that?
So I think,
go ahead, Rehan.
So I think something that's a little bit unique about electrical and computer engineering is that it covers an incredibly broad range of topics that are focused on how we as a society interact and control things like electrons, photons, et cetera, which lead to things like computing, which lead to things like wireless, which lead to things like the internet. And so interestingly, that's a pretty broad range of topics. And so you could kind of say that as electrical and computer engineers, you work on things from all the way down to, making materials, making electronic devices, making computer chips, designing algorithms, writing software, and then even higher level than that, designing systems. I think that the broad strokes answer is that electrical and computer engineers do basically all of that depending on their specialization.
Very cool. Dr. Chugg, do you want to chime in there?
I think that's a good summary. I mean, one of our former chairs always would say, Sandeep Gupta would always say the answer to this question is that he likes to think of ECE as the liberal arts of engineering. Basically, that you get a very broad background because the field is so broad. I mean, even the faculty on this call, I'm probably towards the spectrum of being more of a applied mathematician, theoretical person. And then several of the other faculty, Professor Kapadia and Professor Povinelli, are on the other end of the spectrum where they're working on materials to develop new devices and new semiconductor technologies. And so we have faculty in our department that work on medical imaging, on wireless communications, on computer networking, on biomedical engineering like MRI, and even on basically very close to social sciences, basically doing signal processing, machine learning for patient care and psychology and in couples therapy and things like that, PTSD treatment as well. So it's a huge spectrum in our department, and our curriculum reflects that within the thrust areas that I assume we're going to touch upon soon, Paul.
Yeah, absolutely. I think that's great. Anything with an on-off switch is what I heard, and everything in between, right?
Yeah.
It's got power running through it.
A lot of times people will say, look at an iPhone, and it basically is a good summary of what electrical engineers do, from the applications that run on it, to the sensors that are on it, the cameras, the radios, the touchscreen sensors, all of that is electrical engineering. So it's sort of the, we all have one, we all have a smartphone, and it's really kind of the pinnacle of the progress of our field over the last 20 years.
I think traditionally there was maybe more of a distinction between electrical engineering and computer science, where electrical engineering would be pretty much like anything that's hardware and just anything that you're building something, and computer science would be like programming that hardware. But I think the lines are a lot more blurred, and there is a lot of programming that goes on in many disciplines of electrical engineering. And so I would say, just to add to that, that, you know, even if you're really passionate about programming, it doesn't necessarily mean that, you know, computer science is the only major for you. You can actually do research in electrical engineering and be an electrical engineer, and for the most part still work with software. So it's kind of like an umbrella field these days where there's a lot of different aspects of it. And I would say, like, a lot of them in some way or form do have some interaction with hardware at the end of the day. So you program for a computer maybe, or you program for an embedded device like an iPhone, and so on and so forth. So I guess that's the only like small tidbit that I had to add on that myself.
That's great. That's going to lead me to a question that I think would be helpful for our guests, in that a number of them are, you know, maybe they have experience with programming, or they've taken a computer science class in high school, like a AP computer science, or just entry-level programming or Java class, something like that. And maybe they're looking at computer science as a degree program, but they also see this electrical computer engineering. What is the difference between studying computer science and studying electrical or computer engineering? Is there a better option?
Well, since I'm the closest maybe to computer science, being more of a theoretical person, maybe I'll start and then others can chime in. So I think the main difference is that in electrical engineering, electrical and computer engineering, there is more of a tie to the physical world, to physical electronics, and to hardware that many of your ideas would run on. There is some of that in CS, and there's some abstraction, but really CS is about abstraction. So when you take your first CS class in college, they'll tell you never write the same line of code twice, you know? And so it's about building and building abstractions on libraries, on top of libraries, on top of libraries. And I think from a cultural standpoint, ECE is a little bit more about understanding what's really going on under the hood, down at the lower levels, and worrying about where your information signals are coming from a little bit more. So if these are coming from sensors, physical sensors like microphones or cameras and so forth, that's a little bit more on the domain of electrical and computer engineering. So if we go back to the iPhone analogy, all the software that's, you know, running at the low level on the iPhone that makes it work, you know, that lets you access the microphones and lets you, you know, control the charging of the battery, and the processor at that low level is going to be more of the domain of electrical and computer engineers, whereas sort of writing an app once the framework is all in place is a little bit more the domain of computer scientists. Although there's a big overlap, and a lot of our faculty are joint appointment, so they are professors in both. And then I think as Paul was alluding to, we have a degree, a bachelor's of science in ECE, and in there's three kind of focus areas that students can concentrate in. One is in electrophysics or physical devices, kind of the domain of Michelle and Rehan. The second is computer engineering. And then the third is in what they call circuits and systems, which is where Professor Sideris and I would be. And so those are the three areas. And then in addition to that, we have a CSCE degree, which is a joint degree between computer science and ECE. And it's kind of focused like the computer engineering track in ECE, but it includes more software. And then, you know, to further show you how many options we have, within the CSCE degree, we have kind of two tracks. One is more CSE, and it's more software oriented. And the other one is more of an embedded systems program. So it's more if you were going to get into, say, autonomous systems like robotics or self-driving cars, where you've got to understand software, but you have to understand also real-time hardware on embedded devices. And when we say embedded devices, we're just talking about how we basically put miniature computers in everything nowadays. You know, sensors on cameras, on the cars, and on all the accelerometers. All that stuff is integrated into many computers that live on a vehicle, for example, and as opposed to, you know, the old notion of a desktop computer or a laptop computer. So that's kind of my answer to the question. Maybe, I don't know if Maybe Michelle or Rehan want to follow up on that?
Yeah, I would say from a different perspective, you can think about it as, in an electrical engineering degree, you learn how to write code, and you also learn how that code actually runs. And what I mean by that is, I didn't study electrical engineering here for my undergrad, but I studied electrical engineering somewhere, and you learn how to write software, you learn how to program computers, but then you also learn how, when code executes, how it actually turns into what you see, and that's kind of what really differentiates ECE from computer science, because in order to understand how a machine turns some random set of text that you wrote into a compiler into an actual program and how it actually works, there's a lot of information that you have to learn, and that includes how hardware works, that includes a bunch of math, that includes things like circuits and areas like that, communications, electromagnetics. And so essentially with electrical engineering, you kind of get a foundation in that. So you learn how to write the code, but you also learn how that code actually turns into something useful.
Yeah, I mean, I would say that ECE really gives you a fundamental understanding of how things work, down to the low-level physics of it, versus as how Professor Chugg and Professor Kapadia just mentioned, computer science, the main point of it is to actually kind of do the opposite. It's to abstract how the computer and the hardware works, so you can write code that generally can work on many different systems. And so, one of the reasons that when I was an undergrad, I chose electrical engineering as my major was because I just love understanding how everything works, and just as a kid, taking things apart and learning how the different things work and how they function. And so, and as Professor Kapadia said, pretty much in any electrical engineering major, you are going to learn computer programming. So even if you're, as I mentioned before, passionate about programming and that's something you want to do, you are also going to get that in electrical and computer engineering. It's just that you're going to go deeper than that as well and learn, how to build the hardware that actually can run this code as well.
So I think this is pivoting a little bit into curriculum, and I think it would be helpful if we could get a sense for our guests what happens in an electrical and computer engineering degree. What are the courses that you end up taking? I'd love to hear from Dr. Povinelli, specifically because she teaches a lot of the physics areas. I think that's a nice transitionary bridge of maybe students have maybe taken a physics class, or they're in a physics class right now in high school. How does that lead to what you end up doing? When we've heard the word physics pop up a lot in this conversation.
True. So another way of looking at EE is if you're a student who really loves physics, but you want to do something practical with physics, EE is a great major. So many of us in our department came in that way, where we had a physics background or applied physics background, and then we were using physics principles to make real things. So part of the curriculum is related to those physicsy aspects. Of course, as an electrical engineer, you take circuits, so you learn about circuit design, you make circuits. Later on, there are projects where you can, we used to have a skateboard project. I don't know if the skateboard project is still happening, but you design a circuit and use it. For example, there was a guitar project where you could design your own guitar. So some of the curriculum, of course, will be about circuits. Some of it will be understanding the underlying physics. So for example, there's a class on physics of how your computer chips work, what the physical basis of a transistor is, that Rehan and I have both taught in the past. There are electromagnetics classes, which are describing how your cell phone signals travel through the air. So when you talk on the phone, or in fact, when you talk right now on the internet, all our signals have to travel back and forth between us, and that signal propagation has to do with wave phenomenon or the physics of waves. And so classes like electromagnetics, you study the wave propagation. There are other classes in the curriculum that are more talking about the communications aspects. So how much information can you send? How do errors accumulate? How could you fix them? And so echoing the themes that you heard earlier, some of the classes are sort of the physics underlying your computer. Some of them are what you do with the computer, how you would use it to either compute or to communicate. And then some of them are hands-on projects. We are excited. We have a new student makerspace. That's Paul, do you know when that's at? Is that actually
Open and functioning right now.
okay? So there was a little blip there with COVID, but the student makerspace is now open and functioning, which is very exciting. And that's a space that's open to Viterbi students to use in conjunction with their classes. And some of our different classes will be using that makerspace as a place where you can do course projects. So we're pretty excited about that. That's, yep, just new post-COVID. We also have a lot of teams. So one thing to keep in mind, in addition to the curriculum and the classes that we teach, a lot of our students are very involved with teams. I know every year I ask students who are visiting, how did you get interested in EE? And many of you will tell me robot team. So you will be pleased to learn that we have many different co-curricular activities that lots of our engineering students are involved with that go along with EE quite well. So the robot team is one of them. There's also a solar car team. There's a concrete canoe team that tends to be more the mechanical engineers, I think. But some of these, and there's actually a very active student makers club. So the student makers club also has a lot of EEs and ECEs in it. And those help supplement some of the theory that you're learning in the curriculum and give you a chance to see how these ideas work in practice when you actually get to build real stuff.
I put a link into the chat for everyone to take a look at the curriculum. We've laid out some kind of one sheet so you can see exactly the types of classes you would take. It also helps explain a little bit more about the specializations and the emphases inside electrical and computer engineering. But is there anything else you all want to talk about when it comes to the curriculum, or maybe specific classes that you teach or have taught in the past and what that covers? Maybe even shed a little light as to what a college class is actually like compared to what they're doing in high school right now.
Yeah, I'd like to say a few things.
Please.
One of the things I want to say, which I don't know if Paul has brought up or if you are potentially aware of it, but is one of the things that makes USC very unique, I think, for ECE is that we have a large faculty. You know, we're a large research department. We have, say, roughly 65 faculty, and we have a lot of research going on, a large graduate program. But our undergraduate program is pretty small. So your graduating class is probably going to be, Paul can correct me, but on the order of students currently in ECE. And so you're going to get to know all of your classmates very well. And in your first semester, you'll typically all be taking the same set of courses. And right away, we get you into ECE courses and give you a flavor of all these different disciplines and different directions. So you'll take a first semester course in linear algebra, which is sort of one of the fundamental topics that we use in electrical engineering for more abstract signal processing, theoretical type of work. And you'll take a course in computational programming and computational thinking. And then you'll take another course that's basically an extended conversation that we're having now, which is Introduction to Electrical and Computer Engineering. And those, so you'll all be going through that together. And so you all get to know each other, and that kind of starts you on your path of learning all these different areas and getting a broad background. So we mentioned there's kind of 3 core areas in ECE, the curriculum-wise, and those are in the electrophysics, physical electronics, computer engineering, and then circuits and systems. And so you'll each take courses from all of those areas if you're doing an ECE degree. And then at some point, you'll take more courses in one of those areas that you're most interested in. So you usually choose one of those core areas. That's kind of a little more detail on the curriculum. Again, I'm more on the theory side. So the courses that I teach for undergrads are typically at the junior level, although I've taught the freshman academy, which is a wide class for introduction to engineering and USC in general. But I typically teach a class in probability and statistics, which is kind of an applied math within the ECE. And then I teach a course called Signals and Systems. And you heard Professor Povinelli talking about, we have to get signals from point A to point B. And we've talked a little bit about abstraction in computer science. So that course is really about abstracting signals and things that manipulate signals, called systems, in a very in a black box way. So we don't really care if the signals are audio, if they are, video, if they're seismic signals, whatever they are, there's some signal, and then we can process those signals to change some qualities or extract some kinds of features that we want. So it's a very abstract class, but it's sort of a core way of thinking that underlies the areas of communication systems, signal processing systems, control systems, and machine learning. And that's very unique to electrical engineering. You would never take a course like that in a math department or a physics department or a computer science department.
Yeah, picking up on that, if you're thinking about which major you're interested in, EE is a great major. If in high school you really like physics and math and doing practical stuff with them, and maybe also building stuff. Some combination of those four things, EE is a great major because you get to do very advanced math and you get to use very advanced math, but in a very practical way to understand things like how to make our communication systems better, how to make our, how do we, even if you want to use computers to recognize faces, if you want to do facial recognition, if you think about a generic problem like that, how do we get computers to recognize people? It's uses all those elements that we're talking about. You need sensors, you need cameras, you need math, you need signal processing. So it brings together all of those different aspects and disciplines into a major that's good for people who like math, physics, and doing practical stuff with it.
The only other thing I had to add in terms of the conversation between electrical and computer engineering versus computer science is I've definitely had undergraduates come to my office and ask me before they've been concerned in terms of they see that there are a lot of job opportunities open that are computer science related at big companies like Google, Facebook, Apple, so on and so forth. And they're like, I'm more interested in electrical engineering and I really love hardware and physics and stuff, but I'm concerned that if I get an EE degree, that it's going to be hard to find a job afterwards. And I think that couldn't be further from the truth. I think as we are kind of mentioning here, you learn programming. And so even if you want to do a programming related job, there's nothing that precludes you from interviewing for that and getting that afterwards. I know plenty of people that I went to school with that got electrical engineering degrees and they're actually doing software now. And I know same number and more people who are actually doing hardware and they are gainfully employed in industry and doing great. And so you should definitely not make and I've seen, and the only reason I bring this up is because I've had students ask me this and have serious concerns that, hey, I really like the curriculum, I like the classes better and the material, but I'm worried that I'm not gonna be able to get a job unless if my degree says CS on it, because there's so many more, I feel like there's so many more CS jobs, and that's really not the case. It's not true. You will be able to get any job you want that's related, even if it is a program related job with an ECE degree. So just wanted to address that. It didn't come up, but I wanted to make sure that if that is a concern.
Absolutely. Just a reminder, please hold your questions for the time being. We will open up the Q&A in just a little bit. When we do the Q&A, it's not going to be admission or application related. We have another info session for that, and we'll provide some information on how to register for that. My next question is about research. What research, Dr. Chugg, you mentioned there's a lot of research going on in the department. What are those areas of research? I think we've heard these words come out before, but maybe what are the research projects that are happening, and where's the department headed in the future, if we know that? What's new and exciting?
I can take that.
Please.
Okay.
Please, Dr. Povinelli. Yeah.
Sure. So one great thing about applying to USC is that we have a very strong research program in engineering overall, and particularly in electrical engineering. And as Professor Chugg mentioned, you have lots of faculty in ECE relative to number of students, so you have many opportunities to work on research. We have several undergrad research programs at USC. We've just relaunched a program called Curve, and Curve is a really quite convenient new program. It gives undergrads a centralized place to find out which groups have research positions and then apply for those and get paid research positions during the year. So for example, right now, I actually have 4 undergrads in my group who are working as a team with one of my grad students and me. And to tell you a little bit about that project, the project that my undergrad team is working on has to do with how you can send encrypted communications in the visible domain. So we are studying a system where we take an image that looks like random nonsense, the random colors on a screen, and we want the recipient that we like to be able to decode those random colors on the screen, hold up their iPhone, take a picture, and then get a decrypted picture back. Whereas we want other observers not to be able to do that, to just see random garbage. And this is something we're building with the students, where we're looking at trying to build up from something we do in an office with a laptop and a phone to something that you could deploy in the field with someone who had a phone or an iPad and an overflying drone. So we're sort of on this 1-year journey here to try to build up the system and make it work well enough that we can then go and borrow the drones from our colleagues at ICT at USC and start seeing if we can send do encrypted communications over distances. So that's just one project. And along with this, there are probably 100, maybe at least tens, maybe hundreds of projects ongoing. And you can talk to all the different faculty, find out what they're working on, and find ways to get involved. And it's really pretty easy to do that. We have funded opportunities. We also have summer research opportunities. So if you get interested in research, you can apply for those funding opportunities to get paid over the summer to do research. And so many of us in the department work with undergrads. It's a particularly good way to see if you might, I know this is early, you're just in high school right now, but if you have any interest in going on to a PhD someday and getting into a research field, any of our students who are interested in that pathway, they will often do research as an undergrad. So I've had 3 undergrads in my lab just from USC who then went on to do PhDs in either, in one case, physics, in the other case, electrical engineering. And so it's something you can investigate if you have any interest in that kind of career.
That's great. Thank you. Other research anybody wants to talk about? Any other projects, your particular project?
Well, I was maybe just going to add to the fact that, what Michelle said, that, really one of the things is that, a large number of the faculty members from whom you're going to be taking classes have very active research programs, which means, they're getting government funding to run various types of projects in their area. And so just like Michelle, I have had, many undergrads work in my lab, and, some fraction of them, end up deciding that they don't like research and they go into industry. And then some fraction of them, really love research and they go on and they do PhDs. And, I've had students do PhDs everywhere, and as well as, some of them have come back and are doing PhDs with me. And so, I think that there's a huge opportunity to basically do research in almost any area that you're interested in on campus, in the engineering program itself and in electrical engineering. But for that, there's just really what it takes is for you to start knocking on professors' doors, so to speak, and just saying, hey, I'm interested in research. Do you have any opportunities? I'm interested in this area, blah blah blah. And more often than not, you'll suddenly have this whole new world open to you that that's beyond what you would be able to learn or do in your classes.
Yeah, I think we have a really good trade-off that way at USC. If you look at all the different engineering schools that are out there, there are some very large engineering schools with really great, excellent, active research programs that are so big that as an undergrad, you might get a little lost. Like they're great schools, they have great research, but maybe there are a lot of undergrads in the program and you wouldn't necessarily get that much individualized attention. There are other places that are predominantly undergrad schools, and you may be looking at those, they're undergrad only, so you get a lot of attention, a lot of attention, but not so much really cutting edge research going on. I think we have a good balance in our undergrad program in that we have a cutting edge research program with many opportunities to get involved, but the undergrad population, particularly in ECE, is small enough that you're not going to get lost. You can still get plenty of attention from student services advisors and figuring out what classes to take, in faculty if you want to interact with faculty. I know like last year during COVID, we had a mentoring program where many of us were meeting in small groups with students online. So we wanted to adapt to the COVID conditions. So, I had 4 undergrads that I met with a few times during the semester. Now I know them. When I see opportunities, I forward those to them. And so we're a good size. I think we have a lot of the good features of really, large, strong engineering school, but also a lot of good features of smaller program with more individualized attention.
That's great. Thank you so much for shedding light on all of these topics. I wanted to hand it over to our audience now and have you all ask your questions. So feel free to drop your questions using the Q&A feature. Someone was already ready to go. And I'm going to allow a couple minutes. I'm going to vamp a little bit here. As you see questions, you can hit the upvote number out there as much as you can. Minimize cheating by putting 3 questions into 1 question. So it's up to you all whether you upvote that or upvote others to go to the top, and we will democratically move our way through this process. Once again, I will also say, please do not, we want to keep our conversation focused on the academic discipline, focus our time on the faculty members and how they can help you understand that. Admission, application, scholarship questions, those types of things, that's great for our admission information sessions that are out there. You can register for that. And Michael can put a link into the chat that will help you register for one of those sessions where we can go into that in detail. The one note I do want to talk about with admission, just so I can clarify, we've talked about this difference between electrical, computer engineering, computer science. It doesn't matter which one you apply to. We don't have any impacted programs. You don't have any increased or decreased chances of admission for each one. When you look at all these different programs, if you go watch the computer science faculty session, there's different disciplines of computer science. Really, it's all about what speaks to you the most, what sounds the coolest to you, what are you most interested in. That's what you should put down in your application. And as you start in one, if you realize it's not for you, you can migrate and change to the others. Admitted to one of our engineering programs in the Viterbi school, you're actually admitted to all of them. And so there are people that commonly will switch from CS to ECE, from ECE to CS to CECS, all these acronyms that we got out there, everything with a C and an E and an S, it's all there for you. And we're able to help you out. So just keep in mind, you will be taking classes across these disciplines. So EMI is winning. We're getting these 7 votes coming in here. So I'm going to answer this one live and we're going to see how we do this. Dr. Chugg, you mentioned the CS-CE thread for autonomous systems and robotics. What robotics research is going on at Viterbi? And also, does this become interdisciplinary with mechanical engineering? Let's start with that question.
Sure. Well, we have several of our most recent hires are in the area of autonomous systems. Somil Basil is a new faculty member who just joined us. His research area is in combining computer vision and classic control systems techniques for autonomous navigation of environments using of robotics. We have a new center that's in electrical engineering in autonomous systems. It's centered in electrical engineering, but it's collaborative. There's a number of faculty that participate in it. The lead faculty is Rahul Jain, who's an ECE professor, but there are faculty from the Industrial Systems Engineering Department, the Computer Science Department, and Mechanical Engineering departments at USC. So when it comes to research, the faculty are very collaborative. Many of the faculty have joint appointments. I think Professor Povinelli mentioned she has a joint appointment, and many have joint appointments with BME. And so it's not uncommon for, this gets outside of the undergraduate experience, but it's not uncommon for a ECE core, home department member to have a PhD student who's getting their PhD in, biomedical engineering or mechanical engineering, and vice versa, to have and ECE PhD students supervised by a professor whose home department is mechanical engineering, but they have a joint appointment in ECE. That's why we get joint appointments, so that we can supervise students from other departments.
Great. Dr. Povinelli, you mentioned self-temperature regulating materials for satellites. Is this interdisciplinary research with astronautical engineering? Is there collaborations with NASA or other labs?
Sure, and I see the additional part of that question had to do with physics, space exploration, and remote sensing. Yeah. So ECE is a great place to be for the remote sensing area. And the reason is that so what is remote sensing? Remote sensing is things like observing Earth from space. For example, you might want to monitor crop health from space. And you want to see what sort of information you can get from satellite imagery that would tell you about either, crop health, land cover, water reserves, etc. So we have another faculty member in ECE, Professor Mogaram, who works on microwave remote sensing, and she is an ECE professor. I work on some aspects of infrared remote sensing, and I'm an ECE professor. It's true that there is some overlap with astronautical engineering. We do have a Department of Astronautical Engineering, and they do offer an undergrad degree as well. As an ECE person, well, okay, all those same words we were talking about earlier, like building hardware, understanding sensors, understanding signal processing, doing a bit of programming, all of those things come together in space applications as well. And so the flavor will be a little bit different. I believe the astronautical, we could look at the, it's maybe for another conversation, but the flavor might be a little different whether you're doing more mechanical type classes or more electrical signals and sensors classes, but there is definitely a lot of remote sensing activity within ECE. And for many of the projects that we work on in research, you will find that faculty are collaborating across these departmental boundaries. So if you get involved in research as an undergrad, you may in fact be working with one ECE person, one materials person. You might even be working with a professor from a different department. There's a lot of crossover when it comes to these actual application topics.
Yeah, we often get questions.
And yes, we work with JPL. And yes, yes, I collaborate with JPL. Many of us do. Rehan, I know several of us, I don't know, but okay. Just looking around to see who's in the room. Many of us collaborate with JPL on projects. I have a student who is sponsored by JPL. We use some of their facilities. Our students go back and forth. So many of us have joint projects with JPL staff members and then have students that are taking advantage of their facilities.
Yeah, in fact, I just finished a call with JPL right before hopping on this call with one of our joint projects. So.
And we also have a new project that's starting that's joint funded by JPL. So there are a lot of collaborations between USC and JPL.
Maybe
to give context, JPL
is.
Yeah, to give context.
Is Jet Propulsion Laboratory. Jet Propulsion Laboratory, they're in Pasadena, sort of north of Pasadena.
This is the NASA lab.
It's a NASA facility that built the Mars rover.
Yeah.
Yes. We often get questions similar to this, which is like, I have a very specific idea of what I want to do. I want to do X. Is this discipline, whatever we're talking about, is that the right one to do that? And the space example is great in mind, because space is a classic engineering problem, and that there's never one discipline or one person that does all the things related to complicated solutions to complicated problems in space. And electrical computer engineers are involved, so are computer scientists, so are astronautical engineers, so are aerospace engineers, so are mechanical engineers, so are biomedical engineers, so are industrial systems engineers.
Yeah.
And materials engineers, like all of these things come together. And so what's interesting is that when you're coming from a high school or community college background, you're saying, I want to do X. There's a path to get there. And the question really is, what's your starting point? Is your starting point going to be in the conversation that we've had earlier? When you hear about circuits and systems, is that where you want to start out with the end use application being in space or remote sensing? Absolutely, that's where it's at. But if you're more interested in the propulsion systems, well, then let's go look at mechanical aerospace or astronautical engineering. Are you more interested in the design of the spacecraft? And let's look at astronautical engineering. There's so many different elements to this. that there's never one true path. All of them can end there if that's where you want to go, because it's end use application, and your education will not end with your undergraduate degree. You're going to be constantly learning, whether that's an industry, graduate school, or both. So keep in mind, this is the beginning of a long path. And it's really just much more about like what sounds coolest to you, because you're going to have 4 years of an undergraduate degree with a lot of work in it. You better like the work that you're going to be doing. The end use application is going to come as a result of all that. So that's a great question. I hope that helps answer a lot of these ideas of what's the right major for me. I don't know. It's what sounds cool to you is really the question. Nathaniel asked this question about internship opportunities. Yes, absolutely. I can answer this one. We have internships across all. We've mentioned a lot of companies and organizations. NASA, JPL. We've talked about phone companies, computer companies. Google, Microsoft, Apple. Semiconductor companies. All these companies are recruiting for internships, co-ops, and full-time positions after graduations. We have our full Viterbi career services center here, where we have staff devoted to bringing these companies onto campus to recruit you for those internships, and we help you with that. Students are regularly working in internships and co-ops throughout their undergraduate years, and going on directly into industry afterwards as well, with these same companies. Hsieh asked this question, would you all say that computer engineering is a mix of both computer science and electrical engineering? I'm under the impression that CS is coding heavy and EE is heavily based on working with hardware. Therefore, would CE be a mix of that?
Well, I want to say that EE is not coding heavy. I want to first get that out of the way. It doesn't matter what track in electrical engineering you do, you're going to be learning a ton. Like if you don't like the code, you're going to have a lot of classes that teach you how to code in electrical engineering, almost regardless of what track you do. It's a core component. Learning how to program and understanding how to program is a core skill that electrical engineers learn. You may or may not use it in the future, depending on what you do, but you will learn it. So it doesn't matter what direction you go, you're going to be learning how to code. So I wanted to really jump in and make sure that that's kind of clearly emphasized here. But I think that what it comes down to is the subtleties of what you're learning. Like computer engineering has a different flavor than our electrical sciences area, which has a different flavor than our signals and systems area as well. But I think maybe Keith or Michelle or Constantine can add to that.
Yeah, I'll just add, I just gave you a concrete example. In ECE, you're going to take a course in computer architecture. You're going to learn after you write a text file in Python or C or C++. Eventually, that has to be compiled into assembly code that is specific for the architecture and instruction set for a specific CPU. And at some point, every ECE writes a few lines of assembly code and understands the limited number of operations that can be done on a processor. And then also you're interested in things like, can I do multiple operations in parallel on this processor, right? So a lot of signal processing tasks, you want to do something like a dot product between two vectors. And some processors support that. It's called single instruction, multiple data, SMID. So to understand all of that, that's an ECE core topic, computer engineering topic. In a CS curriculum, you probably are not going to get down to that level. You might talk about the compiler, but you're not going to get down to processor architectures and how that maps onto optimizing code for that specific architecture.
Yeah, I would say that there's nothing more mind-blowing than when you first understand how a processor really works. It's wild.
Very cool. Next question. Inamai is becoming our rock star of the questions and getting all the votes. So congratulations. The next question is, how many undergrad students and grad students in ECE, how many women? I can answer the undergrad questions. I don't have the grad questions. Undergrads, we bring in approximately, it changes from year to year slightly, but around 35 students per incoming class for electrical and computer engineering. But it's a little bit of a blend, right? Because we also have computer engineering, computer science that brings in somewhere around 35, 40 students as well. And that's a mix between CS and computer engineering. So that's roughly it. When you say how many are women, that the incoming class for the last 3 years for the Viterbi School has been 50%. Actually, this year's incoming class is the first class that is majority women in the history of the school, which is exciting. And when you look at each of the departments, although I don't have the exact stat off the top of my head, I think electrical and computer engineering was right around 40% women. So all of these are well above national averages. National average of women in engineering and computer science programs is around 24%. So we're incredibly excited about that. Grad students, I don't know the number of grad students off the top of my head. I don't know if you all do. But one thing that to keep in mind is that they take completely different classes, different schedules, and it's oftentimes you don't necessarily even see them.
Yeah, lots of grad students. We have what I don't even I don't know.
Yeah.
Lots of grad students, but I think as an undergrad, the main place that you would interact with grad students is if you do research and are working in research labs with grad students. Otherwise, as Paul says, it's a different set of classes. There aren't very many classes that have both undergrad and grad participation. Most of your classes are undergrad only.
Yeah, we have about 1,300 master students who are typically on campus for about 2.5 years. And then we have about 340 PhD students who are typically on campus for about 6 years. And the other way that you'll interact with these students frequently is most of your undergrad classes will have a professor, and then they'll have, depending on the size, 1, 2, 3 more TAs. And those TAs are all typically PhD students. So they'll be lab assistants, or you have a discussion session. So you'll have a lecture, which the professor will teach. And then you'll typically have a lab or discussion session, which will be run by one of the PhD students typically. And the majority of our PhD students are international students. So that's always fun for those of you who are domestic born, born in the US and raised in the US. It's great to be able to meet bright young people from all around the world. And it's a great complement to your relationships with your undergraduate cohort.
Great. And Superstar Q&A all-star here, Inam, I asked the next question. Are the classes project-based? Can you, maybe I'm going to expand upon this. Can we discuss this balance of theory versus hands-on? We talked a little bit about some of the projects that are happening.
There, I can start off on this one. So many of the classes are actually project-based, and you get to build stuff. And I feel like this is a very sort of integral and core component of learning is actually hands-on learning, not just doing theory. And so, for example, I teach Introduction to Circuits, and that is typically a sophomore level course, second year course, and that class is not only project-based, but throughout the lectures we actually oftentimes I show a circuit and we talk about how it works, and then we actually have the students, the classroom is in a lab environment. So actually at each desk, there are equipment like power supplies, oscilloscopes, signal generators, multimeters, voltage meters, breadboards, and components. And you actually prototype and build the circuits and see them working in front of you in real time as we go through the class. And then the class projects, Professor Povinelli mentioned that you get to build a guitar. And so that's been one of the class projects that we've done in this class, is we actually at the end of the class, the last 3 weeks of the class is a project period where you take everything that you've learned in terms of circuits and you build circuits that are a guitar pickup. So it actually picks up the signals from the strings, and it filters them and amplifies them and can actually drive speakers. So you can actually hear the guitar output amplified. And the students really like it because they get to actually put everything that they learned in all the theory into practice and build something practical.
That is a favorite class. I see lots of those guitars in my ears here. And sorry to interrupt, but Dr. Chugg, I know you need to head out. And so if you need to head out, feel free to say goodbye to everybody.
I was just going to mention something about the project class.
Yeah.
I mean, we are constantly, our faculty care about teaching. And so we're constantly evolving our curriculum. And so one interesting class, I don't have time to go into it, is called EE250. And it's an Internet of Things class where students actually, it covers everything from my end of the spectrum to the sensor end of the spectrum, and you fabricate your own printed circuit board and you get it back and you build it and you test it and it talks to the cloud. It's a really cool class that was developed about 3 years ago. And so you can just Google USC EE250 and I'm sure there's lots of material online that you can check it out, but that's kind of and that's a sophomore level class. So, and we also have EE109, which is an embedded systems class, which is also, I think that's a freshman level class, your second semester. Sure. Yeah. So those are both very project oriented classes.
Yeah, projects throughout the whole undergraduate curriculum, which I think is distinct from other engineering programs. Sometimes you have to wait to get to the end, and this is something you're going to be doing throughout, which is just a big kudos to our faculty for developing project-based curriculum throughout the entire 4 years, because it keeps you going, it keeps you interested, it keeps you seeing, as Dr. Kapadia mentioned, to actually see how something works and make it work. That's what you're going to be doing from the beginning. Any final notes from you all? Anything else you wanted to comment on before we start closing this out? I want to give you one last opportunity.
I would just say that, there's, this is more of a general statement, but when, whatever you do in as an undergrad, you have a tremendous amount of opportunity. And, to take advantage of those opportunities, a lot of it falls upon you to kind of be aggressive and, knock on people's doors and, seek out people who are doing the things that you might want to do eventually and ask them for advice. Ask them how they got there, ask them what they're doing. And I think being a little bit proactive on that early and doing that often will really set you up for success in a way that just sitting around and passively taking classes absolutely won't. You got to seek out people who are doing things that you would eventually want to do and ask them to mentor you.
Yeah, I agree.
Maybe not actively, but.
When you come, if you come to USC, you take the intro to electrical engineering class. So you get exposed to all these different areas of electrical engineering and what they mean. But I encourage students immediately, as you are taking that class, start applying for internships for right after your first year, because that's where it all comes together. We can sit here and say, oh, there are applications in space, there are applications involving sensors and data, but you need to see it. You need to get into a project where you are actually working on things yourself at a company, at one of the national labs, at JPL, at one of these other organizations, or our research labs in the summer. And when you see what it is that you do as an electrical engineer, then it helps you so much in understanding why you're learning the material you're learning and what you might do with it in the future and how you want to specialize within the major. So my advice is really you want to start as early as you can. We have an awesome career services program in Viterbi. Like our Viterbi Engineering Career Services is great. And their whole job is helping you find internships from the moment that you walk in, getting you involved with internships the year after, So a lot of students put it off. I talk to freshmen and they say, oh no, I'm just gonna go home this summer and, work, babysit, or work with my parents or whatever. And I say, no, start now. Find some engineering jobs to do now as soon as you can, because then you'll see why you're learning all this and why you're putting in the hard work to learn the math and get the math right and get all of the material right.
I just add one last thing.
Now.
I just like to add one last thing is if you come to USC ECE, your classmates are going to be awesome. I mean, we all really enjoy working with undergrads, and that's why we volunteer to participate in this. And the faculty are awesome. You can see all the colleagues here, but even though we're a big research university, the faculty that would teach undergraduate classes, we're all into it and excited. And every year the students just get more and more amazing in ECE, and they keep us on our toes, and we have a lot of fun with them.
And I think you'll find that all of the faculty at USC are super friendly and approachable, and they really care. They care about the students learning and mentoring the students. And so I think the biggest mistake a student can make is basically sort of feeling intimidated and not going to the teacher's office hours, or not sending the professor's emails and saying, I'm really interested in your work. I want to learn more. Maybe I can do research in your lab. And so a lot of students tend to feel shy or feel like the professor is not approachable, and that is completely not true. As Professor Chugg, Povinelli, and Kapadia have been saying, we are all super approachable. We really care about your learning and your futures. And so it's on you to reach out to us to help you and help with any concerns that you have. And then to touch on the internship thing that Professor Povinelli mentioned, it is super important to do internships, and because you will see what the real world is like, what companies are like, and it will help you decide afterwards what you want to do, whether you want to go for a graduate degree, whether you want to start a job immediately. Maybe you'll find a job that you love. When I was an undergraduate, I had the opportunity to do internships, and it actually helped me decide that I wanted to stay in academia. So it could actually help you decide one way or another, and help you learn about what it is, what industry is about, and things are run differently at companies than they are in school and in academia. So definitely, there's no time too soon to start. So even after your first year and your first summer, I did my very first internship the summer after my first freshman year. So highly encourage that.
Well, I have a closing remark, Paul, before you make your closing remark. I think it fits in perfectly to what Constantine's saying. So yeah, you know, you're all here today, you're all in high school and you're thinking about this transition from high school to college. The biggest difference is that in high school, grown-ups are imposed upon you. Between 8:15 and 9, you have to be in some class with some grown-up who's telling you some things. You're going to college next year, and what happens in college is you get to decide which grown-ups, you are a grown-up yourself, and you get to decide which of us and which faculty you want to seek out and engage with. No one makes you go to class. It is best you go to class because you will do better. But you have to decide you're going to class. You have to decide to seek out office hours. You have to seek out faculty who are engaged in research. You have to seek out the student clubs you're interested in, and you will start shaping your own path. So attending today is like the first step. You met some people, you heard some things, you get to decide which of us resonated with you and which advice resonated with you. And then you start choosing your own path, and no one makes you be in any class between 9:15 and 10 anymore. You are figuring out where you want to go. And so, yes, I think what you heard today is that there are many people at USC who are really dedicated to this mission of helping the next generation of students, of undergrads, of grad students, as they follow this path and help develop into engineers. So hope we were good boosters. I think we're all very excited about the school, and hope you will all apply.
Absolutely. Thank you so much, Professor Povinelli, Professor Sideris, and Professor Kapadia. I really appreciate you all and Professor Chugg, who head out. So thank you to him for taking time out of your day to speak to our prospective students. For all of you that have joined us, thank you for joining us. I hope you found this session helpful. There are other faculty sessions that you can go watch the recordings of, and we have a few other departments that are coming up at the end of this week and next week as well. If you want more information on the admission or application process, please sign up for one of our virtual information sessions that happen Tuesday and Thursday. If you're in the LA area, we have our on-campus open house on November 6th. That's all on our website as well, viterbiadmission.usc.edu. If you have any questions for us or need anything else, you can email us at vadmit@usc.edu. Give us a call or text us at 213-600-9919. Find us on Twitter, find us on the gram, wherever else. We're all over the place. We're here for you. And don't forget to start your application if you haven't done so already, commonapp.org or admission.usc.edu/Common App. It's all up, it's ready to go, and it's due by December 1st in order to be considered for merit-based scholarships, and I highly encourage you to do so. With that, I'm going to close it out again. Thank you, faculty. Thank you for all of our guests out there. Have a wonderful day. We'll see you all next time. Fight on.